Welcome back to another Java class. In the previous classes, we were discussing about operators. Let us continue with the operators. We have a few other operators which are available, and we need to complete them very quickly so that we can go to the real programming. So let's continue with the next type of operators, and that is the relational operators. So what is these relational operators? We know that we in real life we try to find the relationship between us and some others. So you may say that he or she is my friend, he or she is my cousin, my uncle. So you try to compare. Now this when you say it's a relationship, usually there is an order. So order could be somebody is elder than you, somebody is younger than you. In other situations, like you try to find who is the tallest person in your class, that is also a relation. There are other situations, like in your class, you try to find out who is the tallest among you. Again, to find who is the tallest among you, you place all of them in an order and you try to find who is the tallest person. So you place all of them in a sequence, one after the other. So shortest and then slightly larger and so on and so forth. And then you determine, okay, this person is the tallest one. So again, this is an order. So in order for us to find the relationship between one and other, we can use the relational operators. There are very two different category. One is a type of relationship that finds whether one entity or one item is very much equal to the other item. So this is the equality. When you try to compare, when you try to say that whether both of them are same. The other one is you try to determine whether one of them is larger than the other one or one of them is smaller than the other one. So these are ordering. So let's try to find the relationship, relational operator that finds the relationship between the operands. One interesting thing is that you must understand is when you have the arithmetic operation, like if you perform x plus y, the result depends on what is the value of x and what is the value of y. For example, if x is 5 and y is 3, you get one different answer. If x is 6 and y is 8, you get some other answer. That means to say that the answer that you get when you perform the arithmetic operation depends on the value of the operand, and the answer may be belonging to one of the specific domain. For example, this may belong to the set of integers, so that may be there, or the other may belong to set of real numbers. But when you try to do the relational operator, the answer could be either true or false. In other words, the outcome of these operations are always Boolean value. You don't get any other type of answers for relational operators. One other thing you must understand is that relational operators are always used with other statement, and generally they are called as control statement, and because you are already familiar with the C programming language. So relational operators are usually used with the if and the looping statement. What are the relationship operators that we have? The first one I have already told you. It tries to find the equality between the two items, like whether one operand is same as that of the other, that is the equal to. Then we have not equal to, which try to check whether the item are different. Then we have the other, greater than, less than, greater than or equal to, or less than or equal to. Let's look at the equality and the inequality. A few things you must understand is all of them can be used with the equality, and inequality can be used with an integer, floats, character, and boolean. Whereas the other type, like greater than, less than, greater than or equal to, or less than or equal to, they can be used with the integer, with the float, with the character, but they cannot be used with the boolean operators. Let's try to look at a few example over here. I'm going to go to my NetBeans, and I'm going to create an integer value. So let's say int 1, int 2, and let's say int 1. So if I use the Boolean operator, and how do I put the Boolean operator? Is x very much equal to y? If I do that thing and run it, I'm going to remove the breakpoint which I have put in the last class. So if you run it, you will get you will know the answer, but you will get the answer as false. The reason for that is the comparison ends up in inequality. So they are not equal, and you notice that it is false. It is not 0, it is not 1, it is false. So you must always understand in Java the answer is either true or false. Now if I go here and then I make it as 2, when the both the entities are, or both the items are same, I run it, and you notice that if I run it, you notice that the answer is true. The reason for it is both of them happens to be true. Now if you try to do the, where is that, okay, if you try to change this one, I'm going to make it as a double. You can make it as float also. I will make it as double, and just to make it as a double, I'm going to give a some double value. So let me zoom it out for you. 1 2 3 4, some 2.1234, and I'm comparing it with uh, 2.1234, and I'm trying to run this program, and I get the answer as a true. What is the difference? This time I have taken a floating point number, that is the double. What if I take a character value and I assign the character, and the character could be any character for that matter. I am trying to find the at symbol, whether the at symbol is same as the other at symbol that you may use in your program. So whether it is the same at, so I'm using the at symbol, and then I try to run this, and you notice that the answer is true. And definitely if I try to compare at with some other letter, capital letter, say W, so capital letter W, so let's run it and let's see how is it going to work. So if you run it, you will notice that they are false, because at symbol and the W are not the same. The last one that you would like to see is that of a Boolean. So if you take a Boolean, and I think I made a spelling mistake. Okay, if you take a Boolean value and the other one also a Boolean value, and if you assign, remember I am not assigning it in a single quote or anything, I am directly assigning it as true, and the other one as also as true. So what happens is true equal to true, and if you run it, the answer is yes, both are Boolean true. So what is the meaning of equality here is that both of them are Boolean true, they are correct, and you definitely you can make it compare it true with false, and you are going to get the expected answer over there, and that answer happens to be false. You can get that. Now let's look at some other comparison. Now what if I try to say whether true is greater than false? If I do that, and when I try to do it, I get the direct error from Java saying that bad. Just place it here. Bad operand type. Binary operators on the first hand side is Boolean. Second hand type is Boolean. You cannot do it. Now, if I try to do it, I get an nasty exception, and I try to do that. I get an exception saying that incompatible, and there is a language runtime error, so it's not possible. Can I put it as greater than or equal to? So again, you get the same error. I don't have to run that and show you. You're going to get it. So with the Boolean, you cannot compare whether one Boolean is greater than the other Boolean or less than the other Boolean. It's not going to work. So you can't do that. Whereas you can do it with the integer or character. Now I can take some character here, and let's say character as dollar symbol. Let me zoom it for you. So I take a character, and I take the other character. One is my dollar symbol, and the other one is my say yes. I think if I put yes, you may get confused. So let me take T. So this is dollar symbol, and I don't know whether you will be able to see it or not. So I'll take it some other symbol, ampersand symbol. Okay, again I'm not sure we'll be able to see it. Okay, I'll take one symbol, last one, percentage symbol, and I then try to compare whether percentage is less than T, and you notice that there is no problem with Java. Java says, okay, that's all fine with me, and I can do the comparison. I can say that whether it is true or false, I really don't know where that symbol is going to come, and it just says, okay, that's true. A T is greater than the percentage symbol. So this is all fine with Java, whether you are using the character, whether you are using the double. I'll have to change the value there, but whether you are using a double, whether you are using a integer, whether you are using a character, as long as you don't venture into Boolean, everything is fine with the Java. So if I try to run it, and by the way, I have a shortcut for this, F6. You can see that if you just press on your keyboard, if you press F6, the program is going to run fine. So this is true because you know that x is less than y. 23 is less than 76. Again, I'm going to zoom it for you. 23 is less than 76, and that is going to be true. So what is the takeaway from this simple demo is, when you try to go for comparing the ordering, that is when you want to check whether one is greater than, less than, or greater than or equal to, or less than or equal to, it works only with integer, float, and character. It will not work with the Boolean type. Now in between, I have not talked about one other type which you are generally using, and that is a string. Now string is fortunately not a simple data type. It's not a primitive type. It is a derived type, and that's actually an object. It is an immutable object. We'll talk about that when I introduce you to the object oriented concept. As of now, it's not the basic type, so you can ignore it. As of now, not that you will ignore it forever. In this discussion, I will not go with the string type. Let's go ahead and let's look at the next type of operator, and that is the Boolean logical operator. Now Boolean operators takes only Boolean value. They are generally used to combine the two results. So again, so like you know very well, if x is greater than y, and if you want y is greater than Z. This and that you are trying to use here is not English and, it is this Boolean operator I'm talking about, this logical operator that is used to combine two Boolean expression. And you have the same old binary equivalent, that is logical and, or, and XOR. Apart from that, you have the short circuit and or, and then you have this unary negation that will simply negate the answer, that is the same as your not operator from the digital fundamentals. Followed by what you have is the compound expression, that is and assignment, or assignment, XOR assignment, and so on. Finally, we have the ternary operator, which is the short form for if then else. Let's look at the Boolean operator. Now, you can use the Boolean operator in the same way as that of the integer, how you have used the booleans in the integer, and I have shown you a lot of demo about that. The other operator that you see over here is the negation, that is not operator. This is used to negate the result. For example, not of true is false, and you know that not of false is true. Just to give you an example, let's try to show it in the demo itself. So I take some Boolean value. I'll take x and y as Boolean. So let me take Boolean, and let me take Boolean, and I'm going to take the first expression as true, and second expression as false. So how do I combine the two of them? So I can say that x and y. So what is the meaning? It is the bitwise and. So what is the first part over here? The first part that you see is the first expression is true. So this is true. Second one is false. And I have already talked about the so-called logical and. In and, even if one of the operand is false, then the result of performing the and operation is always false. So and of this you are expecting it to be false. Let me run it and let me see the result, and you notice that that is false. Instead of this, you can write an expression that is going to give you a true or false. For example, I can write 10 greater than 3. Now, the result of this expression, which is a relational operator, you know very well, result of relational operators are always a Boolean value. So, the end of this evaluation will lead to a Boolean value, and it's going to take that thing. So, if I run it, I get it as false because one of the operand is false. I can also put one other expression here. For example, I can say that whether A not equal to capital A. I'll put a capital A here. A not equal to capital A. Let me run it, and sometime what happens is you end up in trouble because of the precedence of the operators. Now you notice over here the few things. This expression, if you take alone this expression, 10 is greater than 3. So this means this is true. That's correct. Small a is not equal to capital A because I have already shown you the ASCII table in which both of them had a different values. This is also true. And what is the ampersand of that? That is true and true is always true, and that is what you are going to get. True and true is true. So you get the result as a true. In the same way, you can do it with the other type comparison. Now, if you have a true and if you apply, so just say negation operator, so not of x. So what is the not of x? X is true. You look at here, x is true. And what did I do is I am saying not of x. Not of x means not the value of x, which is false. So if you negate true, it's going to be false, and you are going to see that result over here. Let's go ahead with the other type, and that is the short circuit. Now, short circuit logical operators, they are used when you don't want to evaluate the expression which are there on the right hand side. What happens with the short circuit operator is, suppose if you have two expression and you want to evaluate the first expression first, based on the result of that particular expression, you want to evaluate or you want to ignore the evaluation of the second expression. So suppose you have the two expression, you see the result of the first expression. Based on the result of the first expression, either you may execute the second expression or you may not execute the second expression, but you want to evaluate the first expression, anything it could be. So, and you want to ignore the evaluation of a second expression depending upon the result. Now, in this situation, if you use the ordinary or and, it will not work. So, what or and the bitwise or and will do is it will evaluate the first expression. And suppose if you put and here, if this expression is true, it will evaluate the, let's say, I'm going to put it properly. So it will evaluate the one expression. And if this is true, if you have only one and here, and it will evaluate this second expression. Okay. Whether it is true or false, it's going to evaluate the second expression. Now, I don't want the evaluation of the second expression at all times. Sometime I want to do it, but sometime I don't want the second expression to be evaluated. In this case, I can go for the short circuit logical and logical and logical or operators. So what it is going to do is it will evaluate the first expression, and if the first expression is if it you have the and here, if the first expression is false, that means to say that you know very well in the and operator, if the first expression is false, then the result is false itself, because you know very well in the and, if any one of them is false, the result is always false. There is no need to evaluate the second expression whether it is true or false. This result is always false because already one of them is false, you know very well. So if you are using a and here, for example, if you have true and if you get this and, that is ampersand symbol. Now if you get this one true and, now you will have to evaluate. If true and true comes, the second expression is true, then the result is true. If the second expression is false, then the result will be false. So if the first expression is and the second expression, if it is true, then the answer happens to be true. You know that. If the first expression is true and the second expression is false, then the answer is false. So if you have the first expression happens to be true, then you will have to evaluate the second expression, because then if the first expression is true, the result of this depends on the value of the second expression. However, look at this situation. If the first expression is false, and if you have this AND operator, and if the second expression is true, the result is false itself. Again, if the first expression is false, okay, and the second expression is also false, the result is false. So you know that if the first expression is false, there is no need to evaluate the second expression, because you know very well if the first expression is false, the answer is decided by the first expression. Whereas if the first expression is true, the answer is not decided by the first expression. The answer is decided by the second expression. So we can use a shortcut. What is the meaning of saying short circuit? Is if you have, these wires are there. Okay, so this KEV wires are there. I had a power cut, so that's why I am very much fond of KEV now. So these wires are there. Suppose if there is a short circuit here, that's the end of it. You won't get any power at this point because it is all gone. Okay. If there is no power cut, you may or you may not get the power, because if this line is broken, only one line is broken, you may not get the power there. Okay. So as the simple as that, you can imagine that. So if there is a false right at the beginning, there is no need to check the second one, because it is always going to be false. What about the true, the OR? Suppose if the first expression is true, or if it comes OR, now look at the difference. OR is there. Second expression is also true. What is the answer? The answer is true, or true is always true. If the first expression happens to be true, or you have the second expression is false, what is the answer? The answer is true itself. So what's the difference? This is the OR operator I am using. So you know that the answer in this case is decided by the result of the first expression. So if the first expression is true, then automatically the answer is decided by the first expression. There is no need for you to evaluate the second expression. However, if the first expression is false, then if the second expression is true, the result is sorry, this is not AND, the OR operator, the result is true itself. Again, if the first expression is false, or the second expression is also false, the result is false. So that means to say that if the first expression is false, the result is decided by the answer of the second expression, or the evaluation of the second expression. So in this case, if the first expression happens to be true, then you can ignore the evaluation of the second expression, because the result is decided by the first expression. So what Java is doing is, depending upon the AND or OR, you know very well, if it is the AND operation, if the first expression is false, you know that result is decided by the answer of the first expression. That is in case of a AND. If it is OR operator and if the result is true, the answer is decided by the first expression. So Java evaluates the first expression, and if it is a AND like this, what you see over here, if it is a AND here, then it will evaluate the first expression. If this is false, it knows very well that there is no need to evaluate the second one because the answer is already got. The answer of this full expression is already decided. So it will not evaluate the second expression. What's the advantage? Advantage is you will save some CPU cycle because in order to evaluate this one, some CPU time has to be spent. That time can be that processing can be reduced. So this is why it is called as short circuit. Similarly, if it was or short circuit or, it would have done the same thing. So we can use that to trick the Java and to get our way around. So for example, you look at this particular expression here. If the denominator is not 0, that means if this is true, then only you can divide a number by non-zero. Suppose if the denominator happens to be 0 and if you divide a number by 0, then you will get division by 0 error. So you are going to perform this operation only if the denominator is not equal to 0. So if the denominator happens to be false, that means the denominator itself is 0. In that case, there is no need to evaluate the second expression because it's going to create an exception. So this way you can check the first condition, and based on that you can go for the evaluation of the second condition. Now if the Java was to evaluate both of them, you would have got an exception, because if the denominator is 0 and if the Java evaluates this part, so denominator is 0, so this is false, let's assume that, and Java, if it also evaluates this one, then number, whatever number may be there, division by 0 will give an runtime error saying that division by 0 occurred, that's going to be infinity and I can't perform that operation. However, you will not get that error here because of a short circuit operation. In some situation, you may not want that thing to happen. For example, if you look at here, if C is equal to 1, then you increment E++, that is increment E, and compare whether it is less than 100. If C is not equal to 1, in that case, what is going to happen? Because it is a single ampersand, it is not short circuit 1, it's a single ampersand, this one will get incremented. So whether C is equal to 1 or not, it will get incremented because this symbol here is a single ampersand, it is not 2 ampersand. So this is not a short circuit and it is ordinary bitwise and when you have bitwise and, regardless of whether C is equal to 1 or not, this will get incremented. So that is the idea there. Let's look at the one other type of operator which is being used heavily, and that is the assignment operator. So assignment operator is used to assign a value to the variable. So it's a very simple one. You use a single equal and you write the expression. So variable equal to expression. One important thing, the result of the expression, evaluation of the expression, must have the same type or the compatible type of as that of the variable type. For example, if you declare a variable int x and if you assign a Boolean value after evaluation of this, there is this expression, let's assume that there is an expression. If the evaluation of that expression is happens to be Boolean true, then you will end up in trouble because true is non-compatible with the integer type. So when you evaluate an expression, for example, if you write int x is equal to 10 greater than 3. Now you know that 10 and 3 are integers, but because of this greater than symbol, the result of it is going to be true, and that true cannot be stored in integer. It has to be stored in a Boolean. So you end up in trouble. So in other words, the expression that you use here, must after the evaluation, it must have the same type or maybe the compatible type as that of variable which is declared here. The other good thing, like your Python or other programming language, you can go for a chain assignment. What is the meaning of saying chain assignment is you can assign a value directly. For example, you have three integer values. I can say x is equal to y is equal to z equal to 100. So what happens is first it will assign 100 to z, then the value of z which is 100 is assigned to y, then the value of y which is 100 again is assigned to x. So all of them x, y, z will have the value 100. Okay, so just to show you how it really works, let me go over here and let me take three integer values. I'm going to remove all of them. So let's take integer itself. So x comma y comma z. Okay, and I'm going to assign x, anyway you can do it, x equal to y equal to z equal to say 55, and that thing. Now all of them will get the same 55 assigned. So I'm going to print the value of x, y, and z. So let me do that thing. Let's run it and let's see the result. I think there is an error in this result, and that error happens to be because of this. Okay, I will just say this should have been plus. Okay, let me run it and let's see the result, and you notice that all of them happens to be 55. So value of x, y, z, all the three variables are 55 because the 55 is assigned to z first and then to y then to x. However, again, for those who were not listening to me or those who have not watched the first video, you cannot try that thing in the declaration itself. You can't do this x equal to y equal to z equal to 100. This is not possible at the time of declaration. It is not possible. Why it is not possible? For those who have not watched the video, please watch the video, and for those who have watched the video and still don't know, the syntax simply says you can have list of variables separated by comma, not separated by equal. So that is what the syntax says. Syntax says that you can put comma and a variable name, but not the equal sign. So it is against the syntax, and it is not allowed. Let's go ahead with the PowerPoint now. So this is what we have seen. There is the other operator, the last operator, that is the ternary operator. Ternary operator is usually used as a shortcut for if then else. So what the ternary operator will do is it will evaluate this expression, the first expression. If the expression is true, it will evaluate it will take the value of second expression. If the expression is false, it will take the value of third expression. So let me show it with an example. So let's have the value x here. I'm going to just take the value x here, and I'm going to say x equal to 10 greater than 5, which is true. You know that 10 is greater than 5. the I'm going to take 400 some value colon 500. So what's the result of the evaluation of this? So let me run it. I'm going to just print the value of x here and then run it. So when I run it, you notice that result is 400. Why it is 400? What is the reason why it is 400? It is 400 because what is this value? X 10 greater than 5. This answer is true. If this answer is true, if this expression is true, it will take the first value. What is the first value? 400. And that is what it is trying to print here. Suppose if this is not true, let me take 10 greater than 50. So you know very well 10 is not greater than 50. So this value happens to be the value of this expression happens to be false. If this is false, in that case, let me run it. You're going to see the answer as 500. Notice that answer is 500. So what has happened? This case, this particular expression is false. If this is false, it will not take the first value, it will take the second value, and that second value happens to be 500, and you are going to see that as a 500. Now you can complicate this one. So let me take, you can put anything here. If it is equal to, I'm going to just start putting a value for x. So let me take x is equal to 100. Okay, so I can say that x plus plus, or I can say x minus minus. So what you know very well what is plus plus and what is minus minus. So if 10 is greater than 50, if it is true, if this expression happens to be true, then increment the x. If this expression happens to be false, then decrement the value. So if you really want to do something, I can write x is equal to x minus 1. This is one expression I am writing. So look at here, this is one expression. This is one expression. It did not be always one constant value. You can write anything. For example, x plus 5, x plus something. You can write any expression for that matter. It is just an expression. You can, after this question mark, you can write any expression. Okay, any valid expression which will do the some calculation or some equality or some any expression that requires the operands. So if I run this, what is going to be the result? So if I run this, the answer is 99. Why 99? You know very well 10 is not greater than 50. So first part is not taken. So this part is not taken. Instead of this, the second part, because this is false. If it is false, ignore the first part, take the second part. What is there in the second part? Reduce the value of x by 1. And that is what you see in the output here. That is 99. Suppose if I make this as 100. So 100, you know very well 100 is greater than 50. In that case, what will be the answer? The answer will be x plus plus. The reason why it is x plus plus, it is a postfix operation. Let me make it as a prefix. I hope again I'm not confusing you. I think I've already told you. It's let me make it as prefix so that it runs smoothly. And you notice that that is 101. Why it is 100 is because I used our logic and computer logic. My brain works. My brain knows that what I'm supposed to do. Computer knows that what is actually right. So computer just said that you said postfix operation, so I will assign the value first and then increase it, so that you end up in trouble. So this is what happens. It is 101. Hope you get that idea. Let's quickly complete this particular chapter. with the last note on that is on the precedence. So precedence is the order in which the operators are applied. Suppose if you have like this x plus 5 greater than 45, and I can print and because of some restriction, and 34 minus and so on. So in this case, which one will be taken up? Whether the bitwise operator, whether this relational operator, and so on. So there is an order in which these operators. You notice that this is an arithmetic operator. So this is an arithmetic operator. This is a relational operator. This is a bitwise operator. So which one will be applied? Bitwise is applied first, or relational is applied first, or the arithmetic is applied first. To give you an analogy, suppose say you have a road, here, and you are driving on a bike. So you are bike or Activa or anything. Okay, and suddenly what happened? You are here. So let's say in the middle of the road. Okay, so you are driving middle of the road, and suddenly you notice that you get a ambulance. Ambulance comes. So what you are supposed to do? You are supposed to give away to the ambulance, because ambulance has a higher priority. Suppose ambulance is also coming, and your chief minister or prime minister or maybe MLA or somebody is coming there. So what happens in that case? In that case, the ambulance will also give side. It is not supposed to do it, but in general it will give, because this person has a higher priority. Okay, so who is going to be, even though all of them are written in a single line, who is going to be evaluated first? That order is called as a precedence. Which one will get the priority? That is called as a precedence. And the precedence is you have already studied in your very high school or maybe primary. You have this BODMAS rule. Okay, we heard about that BODMAS rule. So this BODMAS rule is actually used for priority, and the same idea is used over here. When you put something in the bracket, that has the highest priority, and the equality, that is the assignment operator, will get the least priority, and the priority is in this order. So remember